Assalamualaikum. In this video, we will study about hydrogen bonding. Hydrogen bond is formed between hydrogen of one molecule and the highly electronegative atom of the other molecule. Let us represent the highly electronegative atom here with X. So, hydrogen of one molecule is bonded with the highly electronegative atoms. So in this case, the bond that is formed between them is known as hydrogen bond. Hydrogen bond is not a chemical bond. It is intermolecular force between molecules. Let me tell you the example of HF. See over here. It is not a chemical bond. It is an intermolecular force of attraction between molecules. It is one molecule, it is the other molecule, and the force of attraction between them is the hydrogen bond. So hydrogen bond is formed between hydrogen of one molecule and the highly electronegative atom of the other molecule. So the bond formed over here is known as hydrogen bond. Highly electronegative atom can be fluorine, oxygen, or nitrogen. So hydrogen of one molecule is bonded with the fluorine of the other molecule by hydrogen bonding. Similarly, the hydrogen of one molecule and the oxygen of other molecule. So in this case, the highly electronegative atoms are the fluorine, oxygen, and nitrogen. You can learn it as FON, right? Fluorine, oxygen, and nitrogen. See over here, we have three water molecules, right? The formula of water is H2O. So I am having three water molecules. This oxygen is highly electronegative and this oxygen is highly electropositive. Now this highly electronegative oxygen will attract this hydrogen. So a force of attraction will be formed between them, and that force of attraction is known as hydrogen bonding. Similar case will happen over here. Hydrogen of one molecule, right? This is one molecule, hydrogen of one molecule and the oxygen of the other molecules will form a bond, and that bond will be hydrogen bond. Now, what was the evidence of hydrogen bonding? Many elements form compounds with hydrogen. What does this mean? That we are having carbon. We know that carbon in its hydride form can exist as CH4. You can take the example of silicon and the other elements present in group 4 of the periodic table. Now what was happened next, that the chemist studied the boiling point of these hydrides present in group 4 of the periodic table. Now see over here, these are the general graphs. In this I have plotted the elements of group 4 of the periodic table. These elements are present in their hydride form. The boiling point of these elements are increasing. It is going in an increasing order. So it is following a regular pattern of increasing order. But when we look at the hydrides of group 5, 6 and 7, we see something different. And where the difference comes, it comes in the first element of group 5, 6 and 7. If we skip the first element, see over here, from here the second elements of the groups are starting. They are also increasing in a regular pattern. Now look at the hydrides of the first element of these groups. Their boiling point is very high, and when coming down in the group, it is decreasing first and then increasing. So the first elements are having very high boiling points compared to that of the other elements of the group. Reason of this very high boiling point was hydrogen bonding that was present between these molecules. In this way, they discovered the hydrogen bonding that was present in the first elements of the group 5, 6 and 7. Now let us go towards the properties of hydrogen bonding. The first property of hydrogen bond is that hydrogen bond is stronger than the dipole-dipole interaction. On the other hand, the hydrogen bond is weaker than the covalent bond. How much it is weaker than the covalent bond? It is approximately 20 times weaker than the covalent bond. So hydrogen bond is stronger than the dipole-dipole interaction, but it is 20 times weaker than the covalent bond. Hydrogen bond is directional. Now the third point is formation of long chain. We know that if I draw the HF, right, the chain goes on. So hydrogen bond result in the formation of long chains of molecules. I told you that covalent bond is 20 times stronger than the hydrogen bond. But the question arises that why covalent bond is 20 times stronger than the hydrogen bond? See over here, we have two types of forces, that is intramolecular and the other is intermolecular force. The covalent bond is intramolecular and the hydrogen bond is intermolecular force. We know that intramolecular forces are stronger than the intermolecular forces. So covalent bond is intramolecular, so it means that it will be stronger than the intermolecular hydrogen bonding. We have this water molecule, right? Now intramolecular forces are present within the molecule. So here it is a molecule and within the bond that is present, it is covalent bond. And now if I take another water molecule, here which bond is present? Covalent bond again, which is intramolecular. Intra means within the molecule, it is present in the molecule. Now the force of attraction between the molecules is intermolecular, and here this force of attraction is hydrogen bond. So now we know that why covalent bond is stronger than hydrogen bond, because it is intramolecular force and hydrogen bond is intermolecular. The second point was that hydrogen bond is directional. What does this mean? For this, consider hydrogen bonding as a bridge. If I draw a water molecule again, okay, here it will be one oxygen. It means that it is pointed from the electronegative atom to the electropositive atom. It is showing a particular direction that the bond is formed between the electronegative to the electropositive atom. Now we have two cases. If the atoms are arranged, if this is the electronegative atom and this is the hydrogen, if this is a linear structure, we say that it has a stronger hydrogen bonding. On the other hand, when it is non-linear, we say that it is having weak hydrogen bonding. But why in linear case there will be stronger hydrogen bonding? In this case, the attraction between the electronegative atom and hydrogen will be maximum. So this is why the bond will be stronger. On the other hand, in non-linear case, the attraction will not be maximum because they will be in non-linear condition. That is why the bond form will be weak hydrogen bond. In this case, we say that HF is a weak acid in all of them. Why HF is a weak acid? Let us see when we draw the structure for HF, and the hydrogen bond will be present over here, right? Now see that this hydrogen is present between two highly electronegative atoms, right? This is the most highly electronegative atom of the periodic table. So this hydrogen is present between the two most highly electronegative atoms. So in the strength of acids, we say that which donate the hydrogen or proton easily, it is a strong acid. On the other hand, it is a weak acid. So in this case, HF is a weak acid. Why? Because the hydrogen is present between the most electronegative atoms of the periodic table. In case of solubility, substances which can form hydrogen bonding with water are soluble in water. Ethanol can form the hydrogen bonding with water. Hence we say that it is miscible with water. So hydrogen bonding also helps in the cleansing action. In DNA, we have this spiral structure and there is hydrogen bonding present in it. Food are stabilized by hydrogen bonding. I hope you all understood this topic, and if you have any problem then let me know in the comments below.